I want to introduce this Sawtooth Lift driven nuclear system, a presentation by Dr. Allan Salzberg, who, as Dave had said, put his legacy as nuclear power. And he doesn't see that he will be living for very much longer, that he may prove that incorrect. But his legacy is this, and he ran for Congress purely for the sake to push nuclear power, because he said, how do I get this question out there? Nuclear power for Idaho. And he was very excited when he watched our video on our website, Nuclear Power, an Inside Story, and the NWAPA project. So,
in 1990, we won the Cold War, and we were the strongest and most wealthy country in history. Yet today our economy is shaky and our industrial base is diminished. Why? Hubris, just overwhelming pride that we are immune to economic laws. 1973, the first energy shock. We talked energy independence, coal and nuclear generators. As a result, we now import $500 billion of oil. We must rapidly reindustrialize and develop affordable, sustainable energy independence. NWAPA is a visionary and enormous geoengineering project that could help reverse these negative trends and increase our security. It makes vast acreage fertile. One pillar of this is our pumping stations, which require large amounts of energy, probably nuclear energy. Idaho is particularly good for nuclear energy because of INL, where a lot of the work on reactors and the fast neutron reactors were done. Energy. Plentiful, affordable energy independence is the basis of our civilization. And without this, our technological civilization ends. It is that simple. We will run out of fossil fuels in the near future as other countries develop and use more of these fuels, increase competition, and in the worst case possible, wars over energy. Our one form of fossil fuels that we have more of is coal, but that has disadvantages, namely its pollution, and if CO2 is important, it is the most CO2 intensive type of energy. Climate change, don't know. It's still up in the air, but it cannot be ruled out. Therefore, it's prudent to move away from the fossil fuels for multiple reasons. Interestingly, though, conservation does not solve these problems. However, it does buy some time and reduce the ultimate costs. It is not a panacea. Wind and solar cannot produce this baseload electricity at any acceptable costs. First of all, they're intermittent. What do you do when the wind isn't blowing or the sun is not shining? You have to have standby natural gas generators, not turned off, but in a low standby mode. It takes about 4,600 250-ton windmills weighing 250 tons to map one nuclear plant. Solar is even more expensive, probably by a factor of 2. Therefore, the claim that nuclear is too intensive capitally to do would hold even less for these other systems. Another point is that nuclear reactors are lasting 60-plus years, where the windmills and solar would be lucky to make it to 30. In 2008, there was a DOE report. It was signed by all the national laboratory directors, including Dr. Stephen Chu, our present energy secretary. In it, it says point blankly that nuclear energy is the only option at the present time to produce the energy we need for baseload power. In addition, it said that for the near term, the new Generation 3 reactors, which are water-cooled, are the way to go. However, further into the future, we will need to move to advanced nuclear designs with recyclable fuel, the advanced technology of fast neutron reactors. What is the difference between a fast neutron reactor and what we have now? In our present reactors, used uranium-235 and 238 mixtures. When a neutron is produced by a fission, it produces the uranium-235 splits, generates more neutrons, and keeps the reaction going. However, when a neutron hits U-238, it is captured and it produces a range of high atomic number systems, such as plutonium-239, plutonium-240, americium, curium, etc. And as a bunch, these are really called actinides, and these are the reasons that the nuclear waste of our present reactors and the Generation 3 reactors has to be stored away for tens of thousands of years. Interestingly, the plutonium that is made during the course of the reaction actually supplies about 40% of the total energy. After the fuel cycle is done, the rods are removed and ostensibly will be buried or disposed of. Generation 4 reactors are different. First of all, their neutrons are not moderated by the water, and when a fast neutron, high energy, hits U-235, U-238, plutonium, or other actinides, it causes fissions to go. So in these reactors, after the run is passed, the fission products, which are the ashes of the reaction, are removed, and the remnants, the remainder of the rods, are reintroduced to the cycle. As you go through multiple cycles, the fast neutron reactors will use about 99% of the available energy, in contrast to the 1 to 2% presently used. In addition, the only wastes end up being fission product wastes, which have shorter half-lives than the actinides, and at 300 to 500 years, they are safe. It is not hard to store things for 300 to 500 years with a high degree of confidence. Something that is not allowed by treaty today, but would be very easy to implement and would be inexpensive, would be to vitrify the waste after they cooled off for about 20 years, place them in stainless steel drums, and drop them into ocean subduction zones. They could not get to the biosphere in any time that could be dangerous. We developed the reactor ERB-2 as a experimental fast neutron reactor. It was developed at Argonne and run at INL in Idaho. This reactor met all its design goals. That's gone. In fact, after 3 Mile Island, they deliberately turned off the cooling mechanisms of the ERB-2 reactor, and it turned itself off. The physics of the reaction are such that if the material gets heated, the nuclei move further apart and the chain reaction ends. In 1994, under pressure from his environmentalists, Clinton ordered the termination of ERB-2, and supposedly even told the scientists not to talk about it. If it weren't for this, we would be ready now. GE Hitachi has developed a reactor whose technology is based on ERB-2. It is called PRISM, P-R-I-S-M, and its lead engineer is Dr. Eric Lowen, L-O-E-W-E-N. It is a modular reactor so that it can be manufactured and the parts shipped, and it is the most robust design now because of its relation to ERB-2. The modular could probably be licensed if an effort were made in 5 years, and could it become available in the early 2020s. These reactors are so efficient that they can produce electricity from 300 to 500 years just using our present waste from the reactors and DOD. And there is enough uranium and thorium with this cycle to produce electricity into the indefinite future. These reactors, because of the modularity and relatively small size, could also power NAWAPA's pumping stations around the Sawtooth Mountains in Idaho. I should note again, the distance from there to INL is quite small. I believe these projects are America's best hope, especially in avoiding an energy catastrophe in the not-too-distant future. Thank you.